In this video, we're going to be going through maximum profit in job scheduling, which is LeetCode problem 1235. So this problem is labeled as a hard problem, and it's fairly popular. It states that we have n jobs, where every job is scheduled to be done from the start time to the end time and has a certain profit. So you're given the start time, end time, and profit arrays. You need to return the maximum profit you can take such that there are no two jobs in the subset with an overlapping time range. So if you choose a job that ends at time x, you'll be able to start another job at time x. So let's look at the first example. We're given these start times, 1, 2, 3, 3, these end times, 3, 4, 5, 6, and these profits, 50, 10, 40, and 70. So the maximum profit we can obtain is from 1 to 3 with a profit of 50 and 3 to 6 with a profit of 70. So these jobs are adjacent, but they don't overlap. So we can include them, and the output is 120. For the second example, input of 1, 2, 3, 4, 6, an output of 3, 5, 10, 6, 9. Profit of 20, 20, 170, 60. The output will be 150, which is the 20 plus the 70 plus the 60. And you notice here the profit is 100, but it takes longer. So the maximum profit is 150. And then finally, we have an input or start time of 111, end time of 234, and a profit of 564. And the profit here is just going to be 6 for the second job. All right, so the best way to do this problem is just to basically go through it. And what we're going to do here is we're going to create a job class, and then we're going to sort all the jobs. So we're going to start by getting all the jobs in order. So we'll create the job class, which will implement the comparable method, which has a compare to method, which will allow us to sort all the jobs. So we'll define 3 integers, the start, the end, and the profit. And then the constructor will take these 3 parameters and assign them to the instance. So this start will be start, this end, and this profit. And then we'll call that compare method, which will pass in other job and compare it to the current instance jobs. So we'll return this.start minus other job.start. And that will put the jobs in order based on start time. And that is it for the job class. Now for the actual method, we're going to pass in the int array of start time, end time, and profit, and pass back an int, which will be the solution. So the first thing we need to do is get the number of jobs. So you can use the start time length, you can use the end time length, or profit length, it doesn't matter. We'll create an array of jobs, and then we're going to loop through the array and assign the start times, end times, and profits. And after we do that, then we need to sort them. So we'll pass in jobs array, and it will come back sorted. And that is it for getting the jobs in order. So now the meat of the code is here. Okay, so we're gonna create an int array of max profit, which is a new integer of the number of jobs. And so what we need to do is figure out the max profit from each of the jobs, together or whatnot. So we're gonna work backwards to do this. So we're gonna start with max profit n minus 1 equals jobs n minus 1 profit. So basically we're gonna grab the max profit of the last job, and then we're gonna compare that to the profit of the previous job. We're going to add that profit, and then we're going to see if the start and end times overlap. And if they do, then we're going to take the maximum profit and drag it backwards through the array, through the max profit array, until we find the max profit, and then the start and end time don't overlap. So we're going to take an int, we'll have create an int array, create a variable int, which will be n minus 2. I is greater than or equal to 0, and I minus minus. So this will be the first job, and then we're going to take the max profit, I, which will be math max of the jobs profit dot I or max profit I plus 1. So the current job's profit or the max profit of the next job. And we start with n minus 2 because we just assigned the max profit to n minus 1, so we don't need to compare it to itself. All right, so the next variable that we're going to define is this j, which will be the job that we're going to compare it to. So that'll be I. It will always be I plus 1, so it'll be the next job in the line, and then we'll make sure it's less than n and increase j as we go. So here's where we check to see if the current job's end time is less than or equal to the next job's start time. So if that is the case, then we have found our solution. So the max profit will be the math max of the current profit or the current job's profit plus the max profit. And then we'll break, and we're done. Close out that for loop, close out that for loop, close out that for loop, and now remember this time we need to return the max profit, the first element in the max profit. Okay, so let's go through the debugger and see if we can't understand this a little better. So here we have, I used the start, end, and profits from the first example. So we have these 3 int arrays, pass those in. So we have a start time, and will be 4, and now we're just going to go through and create these 4 jobs. So start end profit of the first job. We'll do the second one, start end profit of that job. The third one, and one more. Okay. So now we're going to call the sort method, which basically just sorts the jobs. Nothing too fancy there. Okay, so then we create an int array max profit and assign the last, so we assign the last value's profit, the last element's profit, so that's 70. So if we look, I put in the comments down here, put the start and end profit. So we have the max profit of the last entry is 70. So now we're going to loop through, and we're going to take the max profit of either job I's profit, which is 40, or max profit of I plus 1, so 70. So we're going to take the 70, so then we just see how we're dragging this down, to the right, or I'm sorry, to the left in the max profit array. So we have the max profit is still 70. So now we need to compare the start and end times. So if jobs I end time, then jobs I is, what's I? I is 2. 0, 1, 2. So the end time is 5. Is that less than or equal to the start time of I plus jobs J, which is I plus 1? And it is not. 5 is not less than 3. So we go back, and that job, we only loop through there once because that job only has the last job to compare to. So now we'll go to the second job. We'll take the max profit, which is again still the 70, because that job's profit was 10. So now we'll loop through, and if jobs end time, so jobs, or I is now 1, so 0, 1, end time is 4, and the start time of J, 0, 1, 2 is 3. So 4 is not less than 3, so we'll compare jobs, again, still dealing with the end time of 1 and the start time of 1, 2, 3, 3, which is not less than 4. Okay, so we're on to the last job, and doing the max profit again is the 70. So we're going to compare. All right, so I is 0, so we have an end time of 3 and a start time of 2. Well, that's not. 2 is not less than 3. So we have 3 end time, 0, 1, 2. Okay, so we had a start time, an end time of 3 and a start time of 3, so we're good to go. And now we're going to take the max profit of I, which is 50, or we're going to add 50 to 70. And in this case, we add 50 to 70 to get the 120. And that is it. So we return max profit element 0, which is 120, and that is the answer. All right, let's run this through LeetCode and see what we get. Run it through, submitted with that first example, and less than 99.64%, and uses less memory than 78.6% of all submissions. All right, so last thing we'll do is go through the space and time complexity. So time complexity, the time it takes to run, this was O of n squared. We have a nested for loop, so that's O of n squared in that case. And the space complexity is just O of 1. We don't create any, or we don't create any new items. They're all, we get the same thing we passed in is all we use. So, and that's what we got. So thanks for watching. Let me know if you have questions, and we'll see you next time.